Few nutritional assumptions are as deeply embedded as the belief that vitamin C requires plant food. Citrus fruits, bell peppers, kiwi, broccoli. These are the foods that public health messaging consistently points to as vitamin C sources, and this association is so pervasive that most people consider the connection essentially definitional. This assumption was confronted, puzzlingly and insistently, by the observable health of the Greenlandic Inuit, who consumed essentially no plant food for large portions of the year, and who showed no signs of scurvy. The resolution to this puzzle comes from two directions. First, several animal-sourced foods contain meaningful vitamin C, particularly when consumed raw or minimally processed. Muktuk, the skin and attached blubber of beluga or narwhal, provides approximately 36 milligrams of vitamin C per 100 grams when raw. Seal liver, consumed fresh, provides similar quantities. Reindeer liver and brain, walrus, and the fermented stomach contents of hunted animals all contribute vitamin C that cooking would destroy. The Inuit consumed these foods without the prolonged heat application that degrades ascorbic acid, preserving what is nutritionally invisible in a boiled or roasted equivalent. Second, there is an emerging understanding that vitamin C requirements may not be fixed constants, but rather context-dependent variables. Carbohydrate intake, specifically, appears to interact with vitamin C metabolism. Glucose and vitamin C share the same cellular transport mechanism, the GLUT receptors. High dietary glucose partially competes with vitamin C for cellular uptake, which may mean that lower carbohydrate intakes reduce the effective vitamin C requirement by reducing this competitive interference. If this mechanism is significant, then an individual on a very low carbohydrate diet may require less dietary vitamin C than one consuming a carbohydrate-heavy diet, a hypothesis that partially explains why the Inuit, consuming minimal carbohydrates from raw animal foods, avoided deficiency at intake levels that might prove inadequate in a carbohydrate-heavy dietary context. This analysis carries an important caveat for those considering carnivore or very low plant diets. The vitamin C content of animal foods is genuinely present but genuinely fragile. It requires raw or very lightly cooked consumption to be nutritionally meaningful. Well-done steak or heavily cooked organ meats do not provide the same vitamin C content as their raw equivalents. Someone eating a cooked-only animal-based diet without plant foods is not in the same metabolic position as a traditional Inuit consuming fresh raw organs after a successful hunt. Vitamin C deficiency is a real and serious condition. Scurvy progresses to hemorrhage, immune collapse, and death if untreated. Anyone moving toward very low plant food eating should track vitamin C intake carefully and consider targeted supplementation rather than relying on assumptions about what traditional diets achieved under very different conditions.